Okay, we're going to go ahead and take a look at parabolas from a whole lot of different directions. So this first part of the video, we're going to turn the standard form of a parabola. Okay, this is standard form. We're going to put it into vertex form. Well, what in the world would doing that, how would that help me? Well, vertex form looks like this. And this helps me to find the vertex of the parabola, because the vertex then ends up being HK. Okay, so this right here is the horizontal adjustment from the origin, and this right here is the vertical adjustment from the origin. Now this right here is a stretching, shrinking, or reflection. That's a stretch, a shrink, or a reflection. So we don't need to really worry about a movement horizontally or vertically. It's just a kind of a morphing of the parabola right where it is. So this is the actual movement, okay, away from the origin. So let's take a look at how to get the standard form into vertex form so that we can look and know exactly where the vertex is. Once we have the vertex of a parabola, we can tell a whole lot of information about that the whole function. So let's go ahead and take a look at what we would do here. The first thing we're going to do is we're going to remove the constant from the end. The third term, we're going to clear it out, and so we get y minus 20 equals x squared minus 14x. Now what I've done is I've cleared myself a little spot so that I can put my own number in that third position. How am I going to get the number that I should put there? I'm going to look at the middle number here. Doesn't matter whether it's negative or positive, because I'm going to take half of it, and then I'm going to square the results. I'm going to take half and then square the result. So half of 14 is 7. 7 squared is 49. So I'm going to put a 49 there. Because I added a 49 to the right, I must add a 49 to the left. So let's see. Let's clean it up a little bit. So we have y plus 29 on the left, and we have x squared minus 14x plus 49. On the right side, this is actually called a perfect square trinomial now, and we're going to be able to factor it, and it will factor perfectly the same. It's going to be a minus 7 and a minus 7. Now, we've added the 49 so that it would do that. We did that on purpose. We fixed it so that it would actually factor perfectly like that. Now, you can see where we're headed, right? We see that this has been something that's been consolidated. We're going to take our two factors and we're going to consolidate them right now. So we're getting closer and closer to our goal, which is the vertex form. All right, we're almost there. We're now going to go ahead and move the 29 to the other side, and we get y equals, but by the way, this is just an understood one because there's nothing there. We would have had to factor something out to the front. We didn't have to. All right, there's our vertex form. So this means that the vertex of our parabola is actually at 7, negative 29. Okay, now, why did I change the 29 to negative? Because the formula owns a plus, so if I see a minus, that means that the negative must have been put in there by the 29. The formula here, on this one, the formula owns the minus, so the 7 is just going to come out. It was a 7 that was put in because the formula didn't change. So there's my vertex. And of course, this right here tells me about whether it has been reflected vertically or not. And it hasn't, because there is a positive 1 there. In other words, if this is a positive number, whether it's a positive 1, 2, 3, 4, whatever, half, if it's positive, this thing is going to open up. So we know that the end behavior does that. So if we know where the vertex is and we know that it's opening up, we know a whole lot about that parabola. In fact, there's a whole slew of things that we can find out about just having that little bit of information. Now, this has given us a little bit more information than that, but let's take a look at all that they're asking for in this next question. It says, from the graph of the parabola, determine whether the parabola opens upward or downward. That's almost an insult, right? It definitely opens upward. Find the vertex. Well, that's pretty simple. Let's do that. The vertex is 4, -4. The axis, looks like the little F came off there when I copied it. The axis of symmetry. So now what's the axis of symmetry? Let's take a look. That is the place where we would fold it and it would be the same on each side. So the axis of symmetry is always going to go through the vertex, right? Well, if that's my axis of symmetry, then I want, it's actually a line, and so I'm going to write an equation of that line. Well, a vertical line is always written as x equals. A vertical line is always written as x equals, and it's always written as x equals whatever the value, whatever the place is through which we pass the vertical line. In other words, through the 4. You might be saying, well, won't that always just be x equals the x coordinate of the vertex? Yes. If it's an opening up or down, if it's a parabola opening up or down, yes. The equation of the axis of symmetry right here is always going to be x equals whatever the x coordinate is. Okay, makes sense, doesn't it? All right, so we've got the axis of symmetry. Let me label that axis of symmetry. There's the axis of symmetry. And the range of the function. Again, if I know the vertex, then I know the range. Well, the range is as if all of these points flew quickly to this y-axis as if it were a magnet, right? All these points flew over there and they attached themselves to that magnet. Well, what would be colored in or covered up with blue metal pieces would be -4 would be the smallest number, right? -4. It would go down to -4 and no further than that, and it would go up to infinity. Now the metal pieces, I've said in some previous videos, if this parabola was made up of a bunch of little blue metal pieces, they would go as fast as they can over here to the y-axis if we turned on the magnet of the y-axis. So that's how you can think of the range of something. So it's going to go as fast as it can over to the left. It's going to attach itself to the y-axis magnet, and what will be colored in will be -4 to infinity. So it's going to keep going up. And there's my range. Pretty simple way to do range. All right, let's see. It says find the maximum and minimum value. What's the maximum? Well, there's no maximum value for this thing. This goes on forever, up. But it does have a minimum value, right? Has a minimum value. So the minimum value is 4, -4. We're going to call that the minimum. There's the minimum at 4, excuse me, yeah, 4, -4. Had to double check myself there. Let's take a look at what the rest of it they want is the intervals on which the function is increasing or decreasing. So let's take a look. If my ant, if you looked at previous videos, the ant is just crawling along the the parabola. He's crawling along the parabola, and all he can do is go from left to right. That's all he can move. He can only move from left to right. So if he's moving from left to right on the parabola, then he's going downhill, meaning decreasing. And what are his boundaries? His left boundary is -infinity. His right boundary is at 4. Okay, so there's the decreasing interval. The increasing interval is from 4. He's actually now going to be going uphill. He's increasing. Once he gets to the 4 on the x, he's increasing from 4 to infinity. And remember, these right here are never talking about the y values. They're talking about x values. Lined up with what? X values. Okay? So, Let's see what else they want. I think we finished it up. Determine the parabola opens upward or downward. It goes up. Find the vertex, axis of symmetry, range, minimum or max, and intervals, x intervals where it's increasing and decreasing. All right, one last thing and we'll be through. Here's an application. Why we need to know all of this. This is allows us to solve real life problems, something like this. Suppose a baseball is at 3.5 feet above the ground when hit straight up with an initial velocity of 80 feet per second. Here's the function. D of t, distance as it relates to time, is negative 16t squared plus 80t plus 3.5. There's the function. That gives the ball's height. Okay, so it's distance above the ground, the d of t distance, or we could call it h of t, as a function of time, meaning, okay, it depends on time. All right, so time in seconds. It says, what is the greatest height of the ball? Well, here's what we're talking about. Let's just give ourselves a little sketch. We hit it at 3.5 feet above the ground. It's going to go straight up, and then oops, sorry about that. It's going to go straight up, and then it's going to come back down like that. Now, we want to know what's the height that it reached? Well, if I could figure out the vertex, right, the x value, I could find the y value. In other words, what's the vertex of that thing? So, this would be really difficult to put into vertex form, right? That would be very difficult. So I'm not going to try to even put it into vertex form. No way. I have another way to do it, though. We have a kind of a shortcut to get the vertex of a parabola, and that's this. If I have this in standard form, A, B, and C, okay, there's the A, B, and the C, then I can do this. I can get the x coordinate by saying negative b over 2a. Negative b over 2a. So let's get the x coordinate of the vertex by doing that. So we have negative 80 over 2 times negative 16. Let's clean that up. Let's see what we get for the x coordinate of the vertex. So it looks like we get negative 80 over negative 32, which is going to be a positive 2.5. So what does that tell me? That tells me that 2.5 seconds into the hit is where it's going to be at its highest point, that ball. Well, I don't know what the highest point is, and that's what the question, the greatest height that it reaches, that's what the question is asking. So all I've found so far, I have found the x-coordinate of my vertex, not the y-coordinate. How in the world would I find the y-coordinate? All I have to do is dump in that 2.5 seconds, right? That's 2.5 seconds. Dump it in to the value of t. So let's dump it into the original equation. 2.5 is going to go in for t. 80 times 2.5. Whoops, giving myself a little separation here. There we go. Let's see what we get. Okay, so we get negative 16, and that's going to be 6.25 plus, and this right here is going to be 200, 80 times 2.5, and then there's the plus 3.5. So let's keep on going, and we get negative 100 plus 200 plus 3.5, which gives us 103.5 feet. In other words, at 2.5 seconds, that ball goes to a height of 103.5 feet. So that's the place right here. That is going to be 103.5 feet. That's how high that ball goes. So we have a little shortcut here. Again, finding the vertex of a quadratic or that creates a parabola on the graph. We can find it using this formula here. Once we get the x-coordinate, all we have to do is dump in the x-coordinate into the original function, and we find our final height. Okay, hope this was helpful. Thanks for watching.